In this video, we'll be doing a fresh example of using the critical path algorithm to schedule a series of tasks onto processors. So we're returning to an example which we solved via decreasing time algorithm. Let's just change it up and see what we get when using the critical path algorithm. Sometimes it'll be better, sometimes it might be the same. It just kind of depends. Every project is so unique with the way that with the way that the prerequisite graph is set up. But first of all, step one with the critical path algorithm is to find all the critical time. So we need to start by backflow algorithm, find all the bracketed numbers. That will give us our priority list, and once we have our priority list, we're good to go. So that's always the goal in these problems. What's my priority list? Then we go. So starting from the end, critical time of the endpoints are always the same as their processing times because they have no paths from there. And then when we work our way back, so F2 only has one target, so we're just going to add 2 plus 4 is 6. G only has one target, 4 plus 3 is 7. And be careful when you have more than one target. Like D has two targets, 6 and 7, so we're always going to choose the larger number. So it's going to be 4 plus 7 for 11. And E has two targets, 7 and 8. Always add the larger number. 8 plus 4 is 12. And we're always adding the number in parentheses to the number in brackets, and always picking the largest bracket. Which again, if that we discussed kind of why that was in the case of the backflow algorithm video. So again, if you want to know why that, refer back to that point. But the essence is, the critical path is always going to follow the biggest numbers, so we're only choosing the biggest. We're not adding them together. Well, you're adding the processing time because we want to find the new critical path from the new point. Anyways, now that we're at A, we're choose the larger number, which is 12. 12 plus 2 is 14. From B, we have two targets. Choose the larger number, 12. 12 plus 3 is 15. And from C, there's only one target, 12. 12 plus 4 is 16. And the critical path is always follows the largest number. So 16 is the largest number on the graph itself. So this is going to be where we're going to start, and it's going to trace through larger numbers. So, well, there's only one path from C to E, and from E we're going to go to the largest number, which is 8, and that finishes our critical path, which is CEH. And some of the online homework might ask you to find the critical path. That's if that's what it's asking, that's all you need to do. And then the critical time would be 16. Again, we're not told if it's in hours or minutes or whatever, but let's just say hours, 16 hours or whatever, and the path CEH. I noticed that this one, it doesn't seem to go to the end, but remember that like every point at the end of this would be connected to the end because we have to finish everything to finish. And since H doesn't have anything relying on it, it is really an endpoint, not it, even though it's listed. It looks a little different if you see what I'm saying. But also, if we're trying to actually schedule it, we're not quite done because all we've done is we found the critical path, we found all the critical times. Now we have to actually make the priority list and schedule the tasks on the processors and figure out who's doing what when. So the priority list should be prioritizing longest first. So C is the biggest critical time, 16. Then it goes BA. Now E is 12, D is 11. H is 8, G is 7, F is 6, and I is 4. And there we have our critical time priority list. And now we just schedule. So what's also very nice is, which is pretty typical, is that the tasks at the beginning are all the ready tasks. CBA are all on the left. They had no prerequisite task. So I just know that I'm scheduling C first, 4, and B second, 3. And B is going to finish first, so they're going to get the next task, which is A, which had a total of 2 hours. Remember to use the parenthesis numbers, not the brackets, when you're actually building the schedule. but we're using the brackets prior. So B is now finished, C is now finished. After 4 hours, we could check to see if anything is now ready. But if you recall when we did this problem before, both D and E had to wait for A to finish. So there's no way we're getting around that. And so far, I think the schedule looks exactly the same as decreasing time. And now we have A's finished after 5 minutes. Now E and D both become ready, which both have times of 4 minutes. Schedule those two next. Then H, G, and F become ready. And if so far we've got exactly an identical solution, so we can tell there's not a huge difference. But notice that in the priority list, we're just really following right along. It doesn't really jump around much more convenient and less frustrating than the priority list that we had generated from decreasing time method instead of critical. So in summary, the critical time is just way easier to use. It's a little bit annoying to find those critical times, but it's much more helpful to use that when scheduling. And it just makes life a lot easier. So H is going to be next at 8 hours, putting us at 17. Meanwhile, processor 2 can work on G, then F, which are 3, then 2. And finally I, which is 4 hours, which would then lead us to the completion of the project after 18 hours or whatever, which we could actually go compare to our prior solution from decreasing time. And yes, it's actually exactly an identical solution. GFI, yeah, I think it's exactly identical. GFI, exactly identical, which is coincidental. It's not necessarily going to be the same, but the priority list itself was quite a bit easier. And ultimately, the critical path algorithm is better. It's more likely to get you an efficient and or optimal answer than decreasing time. And that'll wrap up our talks on Chapter 8. There's an additional practice question in the packet if you'd like to run through that, as well as some videos on MyMathLab. But you should be good to go in working on the homework from Chapter 8 at this point. As usual, hope you all are doing well. Please email me or come to Zoom if you ever have questions or are feeling frustrated, because this is a notoriously tough chapter and it just takes some practice. Anyway, see you next time.